So, first question, open to the panel. So imagine an end user is requesting content addressed video in the near future in the next couple of years. How would you hope that user would find that content?
I can start. I think that a lot of, IPFS has grown big enough that a lot of users have a lot of different requirements and use cases. So I would hope that they'll be able to make the right trade-off they need for their use cases. Like, for example, users who might live in a country that's being censored, right? And they're trying to get Wikipedia. They might be willing to tolerate a lot of latency, right? In order to get more privacy so that they don't get in a lot of trouble with their government. And I think that's fine, and we should have multiple different kinds of content routing to provide for those use cases.
I would hope that when you're looking for something like a video, you're going at furthest to your local region in a Web 2 networky sense. That maybe there's a data center where that video is if it's not popular. But if it is a popular video, if it's news, if it's something that other people are asking, ideally you can find it in your same city, right? There's someone else in your city that's probably watched that video recently. It would be great if you can just have the latency of that. And so I think it's going to be interesting to see how we can evolve content routing to help discover those other locations that are really close to you that also have the content. Because I think that's going to become more and more likely to be true. And the more that we can realize that, the more powerful and value add that we're able to make with content routing, with content address data.
Yes, I agree. I was going to say something. Obviously, like local mechanisms for fallbacks to global mechanisms for finding content. I would want the content to be delivered to me from multiple sources, ideally, and obviously people who are near me first. And if we can get there, that would be great.
Excellent, great. Next question is for Alan. So DAGHouse is currently running a gateway that's offering really great experience, Web 2 experience for its users. So can you talk about how you solve content routing for Kubo users?
Yes, I can. So I guess a bit of background there is that DAGHouse, so we run the Web3 storage service, the NFT.storage service, and we started off by, we had two kind of IPFS clusters that grew very, very big. We had a bunch of learnings from using that before we switched to Elastic IPFS. Like things like you should have a cluster of kind of smaller nodes, and by smaller I mean like smaller disk sizes, because as soon as you have a cluster of like 3 nodes and you put a lot of data on that node, then it's responsible for doing a lot of writing for starters, but also it then has to provide all of that information to the DHT, so there's just a lot of work to do there. And if people put popular content on there, then it's also responsible for content that's quite popular. And if there's a chance that it's going to be the only node that's serving that content, then your responsibilities are just big, and our nodes become very busy and tend to performance kind of in our experience sort of tends to tail off as nodes get bigger. So like ultimately we kind of got to a point where we had to turn off the DHT providing from because our nodes got big. In like we did move to smaller clusters, but it just meant that they were just too busy, and the only way that we could get some read performance out of them was to turn off providing. So that's not great. And I think in Iceland we were talking about how there was a kind of big problem there, in that we had so many CIDs. Like the overhead of like provider records that were being placed on nodes in the network was like 4 megabytes each node or something, which is just quite a lot to ask of every node on the network, and we had lots and lots of records. So The alternative is to change your provider strategy, I guess, from providing for all blocks to providing like just the roots for all of. But we didn't really want to do that. Like I said, if there's a chance that we're the only node that is serving this content, then as soon as you turn off providing for other blocks, you disallow like random seeks into the data, and you are no longer able to participate in bit swaps for subsets of your graphs, and so that's not a good kind of solution. So the way I'll answer your question now. The way that we kind of solve content routing for Kubo users is to lean really heavily on the indexer nodes, and so all of the data that comes into Elastic IPFS is published to the indexer nodes, and that, as you've already seen this morning, it looks like writing a chain of entries of CIDs that we are providing as a content provider, that the indexer node then comes and sort of slurps up at its leisure. So yeah, by leaning on them, I mean, that's not the whole story. I can talk for longer on the Hydra nodes if you like.
No, so I think maybe I'd like to ask a follow-up question for Will. So we've seen some talks yesterday on BitSwap landing in Filecoin and how that ties into indexers. So how do you think that story ties into the future of Kubo being able to fetch as fallback from Filecoin?
Yeah. We're beginning to see with Boost that there's a subset of Filecoin nodes that are running BitSwap, and so look themselves like another IPFS node. Because these Filecoin nodes have a lot of content in general, they're also focusing, like Web3 storage, initially on indexing as the way that they're exporting that list of SIDs rather than trying to publish to the DHT and potentially overwhelm it. So I think between large publishers like both Elastic IPFS, but also Filecoin nodes, we're going to see sort of this increase of these large providers as initial adopters of trying to think about things like indexing to solve that problem.
Excellent, thank you. So for Gus, another question. So currently Kubo has a tier 2 approach for finding content from peers. So there's the direct query and then fall back to the DHT. How do you see that evolving over time?
Yeah. In the short term, like there's already some people doing analysis on like how to change that. Like we just added a knob in a recent Kubo release to be able to tweak this interval. So we're running some experiments now to see like if we can lower it, because the lower you can get it, the faster your queries will resolve. And like this mechanism was added years ago when the DHT was much slower than it is now. And in some cases, like this fallback behavior actually makes queries slower instead of faster, because like many DHT queries will resolve faster than a second. And so if you wait around for a second before you ask the DHT, you might end up just taking longer than you would have. So I mean, there's some tweaks we can make to that. But I think and also this behavior is part of BitSwap, which is kind of confusing. There's like BitSwap has a content routing thing that does this. Our long-term goal with Kubo is to pull this stuff out of BitSwap and make it like a proper content router, so that it's not like complected with the data transfer behavior of BitSwap, and then we can properly experiment with different, like we can just use that configuration that Ivan showed a minute ago to turn this off or tweak it, and so like being able to do that is really important for making changes to it too.
So a while ago, we were talking about hierarchical DHTs, and we've already mentioned the idea of local and then sort of global resolutions. Has there been any sort of progress in that respect? I know there's now like a local DHT. Is there local DHT and the rest of the DHT, or like is it any more fine-grained than that?
There what? I'm sorry, I couldn't hear you. Oh,
yeah.
Yeah, so like a Kubo node by default runs two DHTs. It runs the WAN DHT, which is like the one that connects to the internet, and then there's a LAN DHT, which uses like MDNS and techniques like that to find nodes in your local network, and it keeps those in like a separate DHT. So in a way, there's already been a partitioning of the DHT going on under the hood, and the querying strategy is very similar to the one that we're using with indexers now, where you like query both in parallel and then sort of merge the results into a stream.
Excellent. All right, so open question to the panel. So one of the tensions in content routing is resiliency versus performance, right? So getting the right thing versus the fast thing. So what level of performance do you think is possible in IPFS without compromising resilience? And are there areas that we shouldn't compromise?
Can we have both? Can we have resilience through many performant things that can go down, perhaps? I'd like that. I don't necessarily believe that it's a either or question, but I understand that a lot of things that we're talking about now are more performance orientated at the expense of resilience in terms of they're more centralized than we'd like, I think. But yeah, I'm conscious of that, and I don't want us to continually sort of band-aid things without a real plan for making it less centralized and more resilient. So I just think whatever we do now, we should be have that in mind at the very least, so that we can get to a place where we do have both of those things. And I think it's possible, but we may be on a road that's going to take us a while to get there.
I want to draw a distinction when we talk about resilience. I think there's actually two properties in there, probably more. But the two that I want to call out is there's integrity. Are you getting the right results? And then there's availability. Are you getting results? There's a property around providing records that we've wanted for a number of years, which is signed records, where when a node is publishing to the DHT, or in general saying it has content, it seems maybe plausible that it signs that, and so that other people can't say that it has that record, and so that when you get these records when you're querying, you know that this ID at this location that's claiming it has it, actually it is someone, at least with that ID, that really has said that they have it. And as part of the double hashing work, I think we finally will be getting that, which is very exciting. Because that means that we can go a little bit further on the performance while really just having to think about the availability side. And so for the availability side, you can say things like, well, I'm going to query maybe even a more centralized or just some instance that happens to be near me. I don't have to trust them that much because I still have some of this integrity guarantee through signing of records. And so if I don't have availability, I can fall back to other instances. But I get to sort of have less of a worry about them lying to me and giving me and causing me to spend a bunch of network bandwidths in the wrong way.
Can I ask a question? Is there any I'm interested in that. In that, is there any recourse in the network indexers for adverts that you receive where the provider stops providing that data, or do you just rely on them telling you that they're stopping? Like in the DHT, you get this great kind of if people stop providing the data, then they stop providing it, or they fall off the network, and sort of it eventually works itself out because those records expire. Is there a similar sort of thing in the network indexers?
Sort of. And about half of it is built. So the network indexers for these large providers, one of the things when you look at, why is it frustrating to provide to the DHT is you're re-providing that same SID saying, I still have this twice a day. You're doing it a lot. And so one of the decisions the indexers made is you basically keep your manifest saying, I still have this. And it's not a thing that you have to keep telling it. It's just, I've still got that manifest. if the indexers can't reach the publisher, they can't reach the node that has that manifest, they eventually will drop it and say, okay, I can't contact you at all. I'm going to say you don't have any of this stuff. But what happens if you keep saying, yeah, I've got all this content, but you don't have the content? You're still a node that's online, but you've deleted it and you didn't update the index properly. Maybe that part of the node had an error or fell off. That implementation's bad. And for that, our guess is it's a reputation feedback loop, which is clients that are attempting to query. If they keep failing, eventually that signal should come back where the indexer should delist and say, okay, this node is claiming it has a whole lot of content, but no one's actually successfully getting it. Let's stop returning those results. That's the part that's not yet built.
I guess, so you could randomly test that people have CIDs, like Filecoin spoofer thing?
Exactly. I mean, the index that a provider is advertising is the list of all the SIDs. So someone can download that and then try random ones and see if they're actually able to get it.
That's then so the thing I quite like the idea of is this proof of retrievability thing I've had in my head. Anyway, but that would be rad as a concept. Anyway, sorry.
Yeah, I think Willie mentioned a second ago that it can be like frustrating to publish to the DHT. I thought that was interesting because like it kind of highlights the trade-offs that we make. Like it's frustrating to publish to the DHT because you can't control what you're serving, right? And that's a property that improves the resilience of the DHT and the decentralization of it at the expense of like performance and stuff like that. So like I'm really happy that we're like exploring this space of really high performance use cases and then the trade-offs over there. And at the same time, we're also exploring, options for making much more private indexers that maybe have like worse performance.
All right, next question. And this one is for Gus. So one of the concerns the IPFS stewards have put thought into is keeping the content routing space from fragmenting. So what would fragmentation mean? And do you think it's inevitable?
I think we're already fragmented, and we don't like to admit it. So like I think that for the past few years that IPFS has been around, we've done a really good job of like hiding users from the fact that there is location addressing going on. Which what I mean by location addressing is there's something else other than just the content ID that we're using to fetch data with, and I think that's just an intrinsic property of fetching data. You have to start somewhere, right? You can't fetch data from nowhere. And like we sort of like hidden this behind a veil for a long time and protected users from having to deal with it by like hard coding bootstrap nodes into implementations. But like the growth is growing so much, like the user base is growing so much that I don't think that we can pretend like that's not happening anymore. And there's already like, as far as like fragmentation goes, like we already know that there's a bunch of IPFS networks out there that aren't on the public internet. They're in like LANs or data centers and stuff like that. So like the fragmentation is already there. So I think moving forward, it's just a matter of like accepting that that's a thing and figuring out how to deal with it.
I mean, there's also, there's a lot of content on the web that has a hash that's not accessible on IPFS. And so that's another realm of fragmentation. So we can also think about how we build additional bridges between these disjoint pieces of content address data at the same time that we're growing.
Nope, too late. All right, so this question's for Will. So we've heard a lot about network indexers today. What do the future of network indexers look like?
Yeah, that's a great question. So I think there's a few things that we can expect with network indexing. One thing that we've seen already is that there's a motivation if you are a relatively high traffic gateway to potentially run your own network indexer co-located with your gateway. Because suddenly, if you can preload all of that data, you don't have to go out to the DHT or anything, and you can actually like really reduce that uncertainty and jitter. You just are querying a local database rather than an unknown sort of thing, and so you can get really consistent performance, which is exciting. I think that we'll see a few potential things that are sort of exciting in that space. One of the next logical motivations is you'd like to take the DHT content and pull that also into your local database as a gateway, so that you really don't feel like you have to fall back to the DHT if it's not in the index. And so I think we'll start to see things that scrape the DHT and provide that as a source into indexes as well, so that someone can maintain a local database where they now know whenever I have to solve this content routing problem, I can do it in a millisecond or a few milliseconds. And that's, I think, pretty powerful. I think we'll also start to see, we don't have that much of a caching story. Like we have a global CDN cache for some of these instances, right? Like if we run one, or if Cloudflare runs an instance of the index, we can put an HTTP cache. And so if stuff is getting queried somewhere, you can imagine that subsequent queries for that same SID are quick. But it would be interesting to have an application-specific cache that's actually keeping a little database, doing some more efficient LRU type things, and knowing, okay, this is these individual SIDs. I can store that as compactly as the index itself. I don't need to rely on HTTP caching or sort of these generic caching things that are there now. So I think we'll see more instances and caches and sort of a diffusion of indexing closer to clients.
Something that I'd like to see in the future. One of the things that users of Web3.storage, of NFT.storage are quite interested in is when their data is available more widely to the IPFS network. We can say that we've received their uploads because they generally send us like car files with data in it, but to them that like they don't we almost instantly make it available on to gateways by magic that I don't need to talk about now. But it would be super cool if we could somehow be able to tell them when their data was available to the wider IPFS network after they'd upload it. And so what we see right now is like network indexes. We sort of give them advertisements, but we don't know when they have caught up to where in the chain they are at the moment, and rather than us like polling for that information, it might be cool to get like a callback or something for maybe not on a per entry level, but like we've incremented it by 1 would be super cool. Maybe not practical. I don't know.
So this segues a bit into my next question for Daghouse. So in cases where Daghouse is providing gateway service to your users, so Web3 to storage, NFT to storage, your users are coming to these servers to get their data back. Is there a future where you don't want them to come to your gateway first and you want them to go to the broader network first?
Yes. Yeah, almost always. Because peer-to-peer, but also because it costs us money. It costs us a lot of money to serve that data, and so I guess the interesting thing that you should know is that we run 2 gateways, NFT-storage.link and W3S.link, and they are both special gateways that are actually not really gateways. They're kind of what we call racing gateways. So they actually just race other gateways, and the other gateways provide the service of discoverability and sending us the data. But when our gateways are going through another gateway to get content that's stored on Elastic, that's quite a lot of extra cost that not only us as an organization are having to pay, because it's like egress from Elastic IPFS to IPFS.io, and then they presumably have to pay like either in or out, and then we have to pay out, or to get and we're just shuffling data around a whole bunch of proxies, and so yeah, ideally users would ask the IPFS network, get it from multiple peers, get it from other places that are not just us, because that caused that we have to pay for that bandwidth. So yeah, all the time, with the caveat being we've just released a thing called Freeway, which is a gateway where it's backed by like R2 buckets in Cloudflare, and R2 buckets are kind of like S3 buckets. Almost exactly the same. They have an S3 API. But we now have a gateway in our race of gateways, which is multiple gateways, which serves data directly from R2 buckets, and it's called freeway because R2 buckets egress is free. You don't pay anything to get data out of them. So for content that is hosted by us, we ask the freeway first, and if the freeway can serve it, then that's fine, and if not, then it falls back to other gateways. And so the freeway doesn't need to do that discoverability thing. We're still serving content addressed like IPFS data. It's just not going over libp2p, and it's not costing us a whole bunch of money.
Excellent. So I think we have maybe time for one more open question. So there's a track on this tomorrow, content routing privacy. So currently on the network, reader-writer privacy doesn't really exist. All of this data is open and transparent. So what do you think needs to exist around content routing privacy story?
Privacy. So I think there's a baseline, which is it would be really nice if the content routing story in IPFS and so forth, you feel like you can say this is not any worse than a Web 2-like world, which is like a big jump from where we are, because in a Web 2-like world, it's like you and that service provider and maybe a little bit of like your ISP and some DNS. There's like a few places where things leak, but it's not every participant in the DHT, potentially, every random node that happens to connect to you. So that's a good first step that we should definitely try to achieve, is like be able to say we're at least comparable. And ideally, we should be a whole lot better. And I think at that point, we're starting to talk about novel cryptographic techniques.
So I was going to say that as a service that it is responsible for receiving data and making it available to the distributed network, like we kind of want that to be public and discoverable by everyone, because that's the sort of the idea. But as soon as we get to the state where users are hosting or running their own IPFS nodes, hosting their own data and providing that themselves, I can absolutely see why you would want content routing privacy, because as soon as you don't have that, then people are able to sort of see what data you're hosting, and I can understand why that would be problematic. I agree we need privacy in those cases, but for the use, well, I mean, in the far future, I guess that this problem of there needing to be someone else that's hosting your data for it to stay alive in the network might not be a thing anymore. So then privacy everywhere. But right now, privacy for the small people who are hosting stuff, and publicity for the people like Web3.storage, like Pinata, like all those hosting providers.
I think that's a good distinction to draw, that there are multiple classes of data. There's like large public data sets where you want accountability from the providers, and so you want that I have this large amount of data to be a public thing that people can then try doing retrievals and make sure it actually exists. And so if data is meant to be public and meant to be available quickly, you want that accountability. But that's different from personal data. Like if I'm doing a backup and I really only want it for a relatively small ACL user base, things like that, then I'd really like much less leakage of knowledge of who's accessing it and when.
Yeah, I think there's a lot of well-known techniques for preserving privacy in decentralized ways that we haven't done a good job of exploring, mostly because it's hard because of assumptions that like implementations make. So like as a Kubo maintainer, I'm really interested in finding the right seams in Kubo to like enable this experimentation with this stuff. We already have like researchers who are super interested in it, and now it's just like a lot of it is just an engineering problem of figuring out how to like open the make the system configurable in a way to where we can try out these new techniques.
Excellent. And I think that brings us to just about time. Again, there's a content routing privacy track tomorrow. You can come see that along with libp2p Day. And we don't have time for open Q&A, unfortunately, but these three are here all day. I'm also here. Come talk. Come ask questions. Thank you all so much.
Thank you.
Thanks.
Thank you.